Okay, so let's finish off question number 9, and we're at 9.1.3, where they asked us to whether the graph is concave up or down in this point over here. Now, what you'll need is the second order test, or the second derivative test. And what's important here, I put in a small schematic for you. So what you do is you calculate the second order derivative in a specific point. So for this example, in this graphs, it's calculated in the point C, and therefore you calculate f double prime of C. And you know is when it's larger than 0, it's concave up. And when it's smaller than 0, it's concave down. Okay, so this graph is all you need to know. Then I wrote down here, I took the liberty of writing the gx. Then I calculated g prime of x. And then next I calculated g double prime, or the second order derivative of the function gx. Okay. Now what we need to do is we need to calculate that in the point x. So we need to calculate the second order derivative in the point x0. So for our example, this c value is 0. Well, if I plug 0 into there, I'm just left with 2. And 2 is larger than 0. So I know that I'm dealing with this case over here. So I just need to write it's concave up. And that's worth 3 marks. Okay, so you need to realize that you need to do the second order derivative test. Calculate g prime, calculate g double prime. Realize that the point that you're calculating it in corresponds to x equals 0. And then just solve the equation and know that when that value is larger than 0, it's concave up. In the last part, we're asked, well, we have a cubic function, and they give us 3 little pieces of information to draw that function with. Okay, so we need to sketch the graph of g. The first thing we need is a coordinate system. Let's start off with that. Okay, so in x, we have gx, so x-axis, and y-axis is g of x. Okay. Now, they've given us that the point g3, so the function value of g3 is 0. So something's happening at the x, on the x-axis, where x is 3. Something is happening there. Okay. I also know that the function value at the point x is 0 is 27. That's given. Okay. And then in this third piece of information, they're giving information. You see there's the second derivative. So they're giving information as to the concavity. And the concavity they're giving is, well, for smaller values than 3, what did we see? It's concave upwards. So this is up. And for values larger than 3, it's concave downwards, because that g double prime is smaller than 0. Okay. So they didn't stipulate much more. And so this function can take multiple forms. For me, probably the most, when I had to do it off by heart, my first instinct was to do this. So it's concave upwards, right? Up until this point 3. It crosses that point 3 and that point 27. So my first instinct was to draw a concave curve up until that point. And then I made it concave down from 3 onwards. Okay, so that's one possible solution. That will surely give you your marks. What else? Yeah, that's sort of what I would draw. So you know the function value in this point 3 is 0. So we've got that covered. We've got the function value in the point x is 27. We've got that covered. And we've got this concavity that is upwards and downwards. We've got that covered. Okay? So that I would write as, or draw as a solution to this problem.